This module talks about measurement of fertility and also the data sources. We'll be reviewing definitions of fertility, also learning key measures of fertility behavior, and reviewing levels and trends of fertility around the world, as well as appreciating the significance of childbearing and fertility decisions. So there's several definitions of fertility. First is fertility itself, which is the production of a live birth, also called natality. Then where there's an inability to produce a live birth, that would be infertility. The number of children born alive to a woman is defined as her parity, and the number of pregnancies she has had, whether or not they end in a live birth, is her gravidity. Fecundity is her physiological capacity to conceive, that is her reproductive potential. Infecundity then is the inability of a woman, and also applies to a man, of inability to conceive a pregnancy. A woman or a man can have primary sterility and secondary sterility. So primary sterility is usually manifested by never being able to conceive a pregnancy by the end of their reproductive lifetime. Secondary sterility is the inability to conceive after one or more children have been born. Fecundability then is the probability that a woman will conceive during a particular menstrual cycle. So how many births and infant deaths are there annually in the world? In 2015, there were approximately 140 million births in the world, of which 126 million occurred in less developed countries and the rest in developed countries. There were a total of 56 million deaths to people of any age, of which 6 million were to infants before their 12th month of life. 12.4 million of those deaths occurred in developed countries. So the rate of natural increase is the difference between the birth rate and the death rate. And in 2015, the rate of natural increase for the world was 1.2%. This represents a doubling time of 58 years. And it's easy to calculate this if you use this set of formula on the right. So you can see that the first box shows the population, the base population, P0, times the exponent to the rate of growth, which is 1.2%, times the number of years. And since we're interested in doubling, we're interested in 2 equal to the exponent times 0.012, the rate of growth, times t. We take the log to solve for t. We have the log of 2 divided by 0.012, which is then 58 years. If the world is growing, or if any place is growing at 3%, the doubling time is usually 17 years. So we get our data on fertility from censuses, from vital registration systems, and then from surveys. We would like to be able to see vital registration systems complete and present in every country in the world, but that isn't often the case. Censuses give us data, but not much more frequently than every 10 years. And as a result, we end up relying a lot on nationally representative sample surveys, especially in low-income countries. In the US, this is an example of the birth certificate. We would like to see all births registered, and in fact, in the US and many countries, without a birth certificate, the child is not able to enter school or often engage in other kinds of civic activities without being able to establish their natality. So a birth certificate captures a range of information. And we can also link it with the death certificate, and also in the US with the fetal death record. So as an example, this is the birth certificate for President Barack Obama. His birth certificate was a cause of a lot of discussion back when he was elected, but in fact he really did have a birth certificate, and he was born in Kapiolani Hospital in the state of Hawaii. So this slide shows how we look at fertility behavior by age, much as we look at contraceptive behavior by age. So this slide shows for the United States in 2000 the age-specific fertility rates, as well as the pregnancy rate and the induced abortion rate, and the fetal loss rate. So all pregnancies represented by the red line at the top, and it's highest for ages 20 to 24 in 2000. And you can see that it goes up and then it goes down fairly rapidly. The live birth curve is also similar. There is a gap between the total pregnancy and the live birth rate, and this represents pregnancy loss. That pregnancy loss can be accounted for both by elective terminations or induced abortions, and then miscarriages, which are fetal losses. So you can see that fetal losses tend to increase with age, whereas elective pregnancy termination tends to be more present in the younger ages. By 2008, and notice that the scale has shifted here from what we had before, which went to 250 births per 1,000 women, to 180. But you can see for the United States that the curve has become more compressed, much more vertical, so that there is now the most frequent age at which women give birth is 25 to 29, but it's also spread further to older ages. The abortion rate still tends to be highest at 20 to 24, and the miscarriage rate remains relatively flat towards the older ages. So live births in the United States are seen here in this graph, which starts in 1920 and then goes to 2010. And you can see the baby boom that occurred between roughly 1947 and 1964. And the top curve is the number of births, and the bottom is actually the rate. And the rate has been going down, not very dramatically, but most dramatically actually amongst teen females. So that's captured in this graph for the US in 2010, and you can see the top line represents all young women 18 to 19 years, and then 15 to 19 years, and then 15 to 17 years. And since 2010, the rate has been declining. One of our main measures of the fertility is the crude birth rate, and this is measured by the number of live births per 1,000 population in a given year. So we have the recorded number of births in the numerator, and we have the population at mid-year in the denominator. So this is all persons in the population as of July 1st of that year. The reason it's July 1st is because there is migration in and out of the population, and the mid-year represents more or less the midpoint or the average. It's usually multiplied by a constant of 1,000 because these are not events that happen with huge frequency, and as you'll see in a minute. So the crude birth rate requires having a good vital registration system, or we have to obtain this information from surveys. But it's only a crude estimate of fertility because the denominator includes persons who are really not at risk of pregnancy. It includes older people, it includes children, and so to refine the measure, we have a general fertility rate, which we'll see in a minute. This graph shows the crude birth rate for the world beginning in 1936 going on to 2005, as well as the crude death rate. So the crude death rate is the green line at the bottom, and you can see it starts to decline before the fertility rates go down, and the difference between the two is what we call natural increase. So crude birth rates generally respond to declines in mortality rates, as they have here in this demographic transition graph for the world. These are examples of crude birth rates in different countries or regions. You can see that sub-Saharan Africa has a crude birth rate of about 39 per 1,000 women, and that the lowest here is in Europe and East Asia and North America, with about 12 births per 1,000 population in 2013. So as I mentioned, a more refined rate is the general fertility rate, and in this case the numerator stays the same as the crude birth rate, but the denominator is now women who are 15 to 19, that is, females who are of childbearing age in that year. And again, this is because women are the ones who are considered to be the population most exposed to having having births. So the general fertility rate relates birth to the age-sex group of risk. It is a better measure than the crude birth rate, and it's about equal to 4 times the crude birth rate. You can also subset that measure for only married women if needed. Here's an example of the calculation of the general fertility rate for Uganda in 2010. This shows that there were 1.4 million births in Uganda, and there were 7.3 million women of childbearing age, so the general fertility rate was 196.4, or almost 200. Another way of looking at that is that roughly 20% of women gave birth in that year. You can compare it to any other general fertility rate. Here for the Czech Republic, you can see that their rate is 43 births per 1,000 women, roughly 1/5 of the Uganda rate. We also are interested in looking at birth rates relative to women of given ages. We often look at it in terms of age groups, 5-year age groups. But here you can see that an age-specific fertility rate is the number of births to women at age A divided by the number of women of that age, and again times 1,000. So for Uganda, we've calculated age-specific fertility rates in this table. And the third column represents those rates. And for each 5-year age group, we take the number of births and divide it by the number of women having in that age group. So it's the number of births to women 15 to 19 divided by the number of women 15 to 19. And that gives us an ASFR of 149.9, or roughly 150 per 1,000 women, or 15% of women 15 to 19 having birth in that year. So we plot that, and you can see here that the age pattern of fertility is relatively peaked at the ages 20 to 24. The area under this curve represents what we call the total fertility rate, which we'll see in a minute, but it's the volume of fertility or the level of reproduction in the country in 2010. Birth rates do decline with age, and you can see that 35 to 39 it declines fairly quickly after age 30. If we were to compare Uganda's age pattern fertility with the United States, which we see in this slide, you can see that the US pattern is much more flat for the same year of 2010. And also this is, as another illustration, the age-specific fertility rates for Pakistan in 2013, and comparing urban and rural against the total. So the total is the red line, and you can see rural fertility rates are higher than urban ones. Sorry, you'll have to edit that part out. Okay, in this next graph you see the age-specific fertility rates for Mexico in 1974 and 2000, and again here, much as we saw for the other countries, you can see that there's been a drop in fertility, and also that the age pattern of fertility has definitely declined at the older ages. The mean age of childbearing actually in 1974 was 29.2, and in 2000 was 27.3. So the length of the generation, which we often proxy by the mean age at childbearing, has actually gone down. So okay, I need to do that one again. Okay, so this graph shows age-specific fertility rates in Mexico for 1974 and 2000, and we see that there has been a drop in fertility, and also that the age pattern has shifted towards the younger ages and away from the older or middle ages. The mean age at childbearing was 29.2 in 1974 and 27.3 in 2000. So women are having children at a younger age. So why are we interested in age-specific fertility rates? Well, one important advantage they provide is that they standardize the age. So if you have populations with different age structures, the age-specific fertility rates adjust for age structure. Also, we're able to compare fertility at different ages over time, which is important because we can then see in terms of contraceptive use where there has been a reduction in fertility and whether or not contraception has played a role in that reduction. And we can compare fertility patterns across, as well as assume contraceptive use influences across different countries and populations. So the ASFR is necessary to calculate the total fertility rate. And the total fertility rate represents the average number of children that would have been born to a woman by the time she entered her childbearing if she were to pass through all of her childbearing years conforming to the age-specific fertility rates of a given year. So it's a synthetic measure. It tells us what would have been the average number of children a woman would have born if she'd been exposed to today's age-specific fertility rates. So to calculate it, we return to our Uganda example, and again you can see here that the fourth column now shows the age-specific fertility rate for that age group multiplied by 5 and then summed across all 7 age groups. Why multiplied by 5? Well, because the ASFR for 15 to 19 actually just represents the average for that age group, and there are 5 person years or 5 years of life in that age group. So what we want to do is to get the full area under the curve, and we have to be able to integrate over all the single years of age. So we multiply each age group by 5, and by summing it we get 6380. If we divide it by 1,000, that means that the average Ugandan, the woman in Uganda in 2010, if she were to be exposed to those ASFRs throughout her reproductive lifetime, would end up with 6.4 children. So the TFR is a synthetic measure, and it is independent of the age structure. It's the best single measure we have to compare fertility across populations, but it doesn't actually give us the actual number of births the woman would have based on her lived experience. It's a average experience based on current fertility rates. These are examples of TFRs in different countries in 2013. In this set of countries, you can see that the TFR is as low as 1.3 in Taiwan and 1.4 in Italy, and as high as 6.2 in Uganda. It's 3 in Egypt. So the world has quite varying levels of total fertility rates, but in fact over time these have started to converge such that many, if not a majority of the countries actually have total fertility rates that are below 2.5. We use 2 or 2.1 as replacement level fertility with the interpretation that it takes 2 adults to replace themselves, or 2 births to replace 2 adults. And we allow for infant mortality as well, which is why we often say replacement is 2.1, a TFR of 2.1. So there are some countries in this slide, for example, Taiwan and Italy, Brazil to some extent, which are actually below replacement. And in the absence of immigration, for example, these populations would slowly start to decline. Mean age at childbearing is another measure. You saw this as an example in the Mexico slide. So this is the average age of mothers at the time of birth, and it can be examined by birth order. We can also look at the median age at childbearing, which would be where half of the women give birth above that age and half below. Sometimes it's preferred if there's a skewed distribution of maternal ages. For example, in Armenia, the median age at first birth is 20.4 for mothers with primary education, and it's 24.6 if the mother has higher education, compared to an overall median of 21.8. So sometimes we will use the median if we have skew, but overall we can look at the mean. This graph shows the mean age of childbearing for the United States, having risen from 24.6 in 1970 to 27.2 in 2000. So the mean age at first birth rose from 21.4 to 24.9, or by 3.5 years in this same period. So an older mean age at childbearing obviously means that there is more delayed childbearing. And especially if we look at it for first births, we can see that there is considerable delay of the first birth happening in the United States over this period. So this graph shows how age-specific fertility rates have changed in the United States between 1990 and 2000. If we look at the red line, that represents mothers who are 15 to 19. And again, you can see that that has gone down, as we mentioned before. But you also see with the green line and the blue line, which represent the older mothers, 35 to 39 and 40 to 44, that has been slowly increasing. So that was captured in the shift towards older ages of the age pattern of fertility that we saw earlier. We also are interested in the proportion of women who are childless at different ages, because this represents foregone fertility. Here, these three lines are by the birth cohort of the woman, and you can see that the 1935 cohort had the lowest percentage of women who were childless. The 1960 birth cohort shows the highest percentage childless. So, by looking at the proportion of women who reach near the end of their lifespan of reproductive years, by looking at that percentage and seeing how many are childless, we can also look at foregone fertility. Again, examples of the mean age of mother around 2010. You can see that Germany and Italy have very high mean ages, as well as Japan mean ages for childbearing. The US here is at 28. And again, looking at overall fertility levels being experienced globally, this graph or map from the United Nations Population Division, which can be accessed at that link at the bottom and is dynamic if you access it there, shows that for most of the world now, the levels of fertility within those populations are at 2.5 or less, with the exception of the sub-Saharan African region. But that is changing as well, and the projection is that by the end of the 21st century, that many of those countries will actually have fertility below a TFR of 4. So in sum, like mortality, the building blocks of fertility measures are occurrence and exposure rates. Age-adjusted rates are needed to compare reproduction levels across populations and over time, and that the estimates of fertility for the same population in time from either census, vital statistics, or sample surveys can vary. But we need to monitor the determinants of fertility and their patterns because these are highly relevant for assessing the impact of fertility regulation behavior. So thank you.